Okay, advanced algebra. 2 more weeks left. This week we are focusing on exponential functions. Way back in March, before this whole thing started, we did exponential expressions. And I know it's weird that we're coming back to it, but not my decision. And let's see, this is notes part 1. You can print this out if you want to and follow along. I would just follow along. I don't think you need to write anything on this part of the notes. What we are covering this week is what does it mean when something is growing exponentially. And it's a phrase you hear a lot in everyday life, especially during these times. Yeah. This is an article, or part of an article, that I printed out for you. Government on Thursday, this is about India, by the way, said that the coronavirus growth in India has been more or less linear and not exponential. What does that mean? We're going to talk about that. Here's another article I printed. This guy is an astronomer that works for SETI. You want to know what that is. That's some serious math right there. But he wrote an article about coronavirus, and he said the spread of coronavirus will be exponential, which is bad. But its inevitable decline will also be exponential. So these are terms that they use a lot, and that's the goal of math, is to help you understand how the world works. That's the ultimate goal in math, right? So let's talk about what exponential growth means. So here, page 2, I have an example of linear growth. This is something you're pretty familiar with because you spend a whole year in first year algebra talking specifically about linear stuff. And now we're going to talk about exponential growth. So here's the scenario. If I give you $1 and say it grows $2 per day, so you start with 1 and it's 3, you're adding 2 each time, right? By the end of the 5th day, you have $11. Scenario number 2, exponential growth. Let's say you start with $1 and it only grows at a rate of 20% per day. So start with $1. After 1 day, you have $1.20 because it's growing at a rate of 20%. After 2 days, $1.44. After 5 days, $2.49. And this is a classic question teachers ask students. Would you rather be in this situation or in this situation? So we're going to show you the power of exponential growth. Yeah? Now, on the first assignment, you don't even need to know the equations or how do I come up with these equations. But on the second assignment for this week, yes, we're going to teach you how to write equations, and it's not that difficult. So linear, y equals mx plus b, blah, blah, blah. Start with 1. It's increasing $2 per day. That's an easy equation. So we're going to use that to figure out how many dollars you'll have after 60 days, even though it's right there in the graph. Ignore that. Pretend you don't see that. So, by the way, if you don't have a calculator that is capable of doing multi-step calculations, let me know and I'll show you how to do it on a cell phone calculator. It's very cumbersome, but you can do it. 1 plus 2 times 60. On the 60th day, you will have $121. So after about 2 months, you have $121. Yeah? Like I said, 90% of students, when we show them these type of problems, they go, oh dang, I'd much rather have this, because they don't understand what exponential growth means. And the equation for this one is 1 times 20% to the power of x. So it's exponential, there's an exponent, blah, blah, blah. And just to show you that these numbers are not fake, they came from math, right? So you start with 1, it's increasing 20% per day. On the 3rd day, it should say $1.73. $1.73. There you go. fifth day, 1 times 1.20 to the power of 5. On the fifth day, only $2.49. On the 60th day, oops, da-da-da. Oh my goodness, let me try that again. On the 60th day, da-da-da. This is about to blow your socks off. $56,000. Huge difference. So when they say something is growing exponentially or astronomically, sometimes you hear that phrase, what it means is extremely rapid growth. Those numbers, initially it appeared that it was growing very slowly, but by the 60th day, $56,000. Think about this as number of infected people, you know. Not that many people are dying, and then the 60th day, goodness gracious, right? Linear growth is a lot of times when you're reading an article or they're talking about it in the news, they'll use the phrase steady growth. They're almost synonymous. Yeah. So rapid growth usually implies exponential growth. Sometimes they'll say astronomical growth, and what they're really talking about is exponential growth. So here's what linear growth looks like. Yeah. And here's a graph of exponential growth. And I know what you're thinking. You're thinking, whoa, linear appears to be growing faster. Well, this is a something people do to deceive you. Look at the numbers. They're not the same. So you're literally comparing apples to oranges. Look at these numbers. Not the same. Again, comparing apples to oranges. If I were to take this exponential functions graph and place it on and rescale it so at least the x-axis goes out to 65, then this is what it looks like. Very slow growth initially. But at a certain point, the growth becomes astronomical, rapid, exponential. So right about here is where it becomes exponential. And that is exactly, by the way, how this virus started. Like in February, it looked like this. And then at a certain point, roughly around April, May, it went crazy. Yeah. Okay. But again, this is comparing apples to apples, at least on the x-axis, right? But the y-axis, those numbers are not even remotely the same. So on the next graph, I'm going to put the linear function and the exponential function on the same graph so that you can see the major difference. And there it is. So the red one is the exponential function. The green one, which is the linear one, and you could barely even see it because it barely even registers when we're comparing apples to apples and apples to apples. So that's a trick people use all the time to try to deceive you. They'll change the scale, and most people are so bad at math they don't have the slightest clue that they're being lied to or that somebody's trying to deceive them. That's another reason why you need to learn math and get good at math, so you know when somebody's trying to lie to you. Okay, and then here's another example. Linear, exponential. Initially, linear looks like it's going faster, but once the exponential hits its curve, it's called an exponential curve, by the way, then it grows much faster. Da-da-da. And what's cool about this unit at this particular time is it deals directly with what's happening in the world. Well, not recently. Before 2 weeks ago or 1 week ago, before George Floyd, this is what was in the news, right? So initially, when this all began way back in February, this is the graph that the UK sent to us, showing this is how many people are going to die in the United States if you guys don't do anything. So that's an alarming number. 2.2 million is what they were predicting. But that's if we did nothing, right? Of course, we did stuff. We shut down the schools, closed businesses, closed factories. Boeing shut down, Microsoft shut down, made everybody stay home for a couple weeks, right? And what happened? So that was their prediction, right? As soon as we made any change at all, if we did nothing, which we didn't do, we did stuff, this automatically changes. So that's another thing you have to understand, that this is about math, is that no, they weren't wrong. We did stuff and it affected. It's cause and effect, right? So way back on February 28th, that's when we had the first death, right? 1 month later, let's call this March 28th, April 28th. It was growing very, very slowly, deaths per day. This is what they initially predicted. Ready? They predicted that we would have very slow growth. Oh, by the way, why am I regraphing it? Because this is another thing that they do to confuse people. This is deaths per day per 100,000 population. So, the graph that I'm going to show you is just pure raw numbers. It's not trying to confuse you or anything, it's just deaths per day. Okay? And right around, we'll say early May is when it just goes nuts, right? Da, 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 da. So it's starting to increase, looks linear, and then bam. They were predicting by June we would have upwards of 50,000 deaths per day. Can you imagine that? And then of course it would taper off. If you take pre-calculus, we teach you how to create these mathematical models, by the way. Not as sophisticated or complicated as what they're using, because it's just pre-cal, high school math, right? But so that's what they're predicting. But right around here, we closed down schools, we closed down businesses, told people to stay home, told people to wear masks, wash your hands, etc., right? So as soon as we did that, I think the roughest day we have had as a country only got to about 3,000 deaths per day. Yeah? And that is the new curve, roughly, right? Right about here, a lot of states are opening up, right? All the riots that are happening. So this is what's likely to happen is, okay, it might go up a little bit more because all the people-to-people exposure that's taking place. Yeah? So every time there's a change, the prediction has to change. That's the bottom line. So it's not that they were wrong. It's we do stuff and it affects the outcome. Cause and effect. Yeah? Okay. And oh, by the way. So in that one scientist was saying in the initial article I showed you guys, he said spread will be exponential, decline will be exponential. So let me show you what that he's talking about. Right here, the purple part, that's exponential. But it's also exponential here. It's also true with the other predictive models that at a certain point it explodes and then it comes back down, usually not linearly but exponentially. This is where we're at, roughly, right? So these are just cases, not number of deaths, just number of cases. So right about here is where it became exponential for our country. Obviously different for Italy, for China, etc. Exponential curve right there, exponential growth. And this is roughly linear, yeah? From here to about right there is roughly linear. But what you can tell is going to happen is it's going to taper off at some point. A lot of the experts are predicting mid-June to late June, right? And then it's going to go like that. Yeah. What's that look like to you? Quadratic, of course. And this right here is exponential. So that's why we study all these different functions. Linear, quadratic, exponential. I'm going to abbreviate exponential with like that. Okay. This part of it is quadratic. And like I said, if you take pre-calculus or higher level math in college, you're going to learn a lot more math. Yeah. But this week we're only talking about exponential functions. And there are two types of exponential functions. You got exponential growth and you got exponential decay. Voila, let me graph both situations for you, and then in the next video, shoom, that's what exponential growth looks like, always. Exponential decay looks like this, always. So, next video, we're going to focus specifically on the pure math, not the cool, interesting stuff. Yeah, cool and interesting stuff. The dull and boring stuff. But you got to learn dull and boring first before you go to complex stuff. Yeah. So, next video, back to boring.